It's literally right under our feet, but we've never, ever seen it. I'm talking about the Earth's core, of course. So today, we're going to change that. We're heading out on a wild, hypothetical journey to drill all the way to the center of our planet. Let's get digging.
So, just how far have we actually managed to get on our own? It's kind of crazy when you think about it. We've sent people to the moon, we sent probes rocketing past Pluto. But when it comes to exploring in the other direction, we've barely even scratched the surface of our own world.
And this slide really puts things into perspective, doesn't it? Our current record holder is the Kola Superdeep Borehole in Russia. It went down 12.3 kilometers. That's an amazing achievement. But the full trip to the core, that's over 6,300 kilometers. We haven't even gone 1% of the way. Not even close.
So our epic journey kicks off in the layer we all know best, the crust. This is where we'd start, using our most advanced, real-world drilling tech. But you'll see, even this close to home, things get extreme, and they get extreme fast. As we start drilling down through all that familiar granite and basalt, the temperature just skyrockets. We're talking up to 1,000 degrees Celsius. At that kind of heat, even our toughest, most futuristic drill bits would just melt. They'd snap. They'd be completely useless.
And that is the real kicker here. The insane heat and pressure don't just melt our drill, they actually change the rock itself. It stops acting like a solid, It becomes this gooey, plastic-like substance that's basically impossible to drill through with any normal methods.
Okay, so conventional drilling is a no-go. We need some new tech, something straight out of science fiction. So let's introduce our first hypothetical gadget, a gyrotron. Think of it as a massive energy weapon on the surface that fires a concentrated beam down a tube, a beam so powerful it literally vaporizes the rock in front of us. This is how we're going to conquer the crust.
We're through the crust, but honestly, that was just the warm-up. This next layer, this is where the challenges really start to pile up. Welcome to the mantle, the massive layer that makes up more than 80% of our planet's entire volume.
Just look at these numbers. They're mind-boggling. The depth is almost 3,000 kilometers of solid rock. And the pressure? It's over 1.3 million times stronger than what we feel on the surface. The heat blasting out from the tunnel walls alone would be enough to just incinerate pretty much any material we know of.
And here it is. This is the single biggest problem in the mantle. If the crust was like drilling through hot plastic, well, the mantle is like trying to keep a tunnel open in a giant vat of thick, scalding hot peanut butter. With all that pressure, the tunnel would just squeeze shut almost as fast as we could vaporize it.
So, how do we solve that? Well, the short answer is we can't. This is where our journey hits a massive technological roadblock. We'd need some kind of futuristic tech that could instantly crystallize the walls of the tunnel right as we drill, making them strong enough to fight back against the pressure. And right now, that technology just doesn't exist.
But hey, this is a hypothetical journey, right? So let's just say we figured it out. This slide really lays out our next two big hurdles perfectly. Down in the mantle, the issue is drilling through a solid that acts like a liquid. But coming up next, we have to get through an actual liquid. The whole game is about to change.
After what would feel like an eternity of drilling, we've arrived. We are no longer digging through rock. We've officially breached the outer core, a churning, planet-sized ocean of liquid iron and nickel.
The conditions down here are almost impossible to wrap your head around. The temperature hits 6,000 degrees Celsius. We're talking as hot as the surface of the sun. And since it's a liquid, our fancy laser drill is now totally useless. Think about it. How do you drill a hole in a liquid? You can't.
So what's the plan? Well, the solution is actually pretty genius. We stop trying to drill, and we just start sinking. The idea is we'd build this massive, indestructible pipe out of some material that's even denser than the liquid iron, and then we just let gravity do all the work for us.
And get this is the really wild part. Even though this liquid iron is 10 times denser than water, its actual consistency is about the same. It's not thick and sludgy. So what that means is our pipe would just sink right through it with very little resistance. It would travel that entire 2,260 kilometer stretch in just over 5 days. Incredible, right?
But of course, there's a catch. That swirling ocean of liquid iron is what generates Earth's magnetic field. And down here, those magnetic forces are 50 times stronger than what you'd experience on the surface. All of our electronics, all of our navigation gear, totally fried. We'd be sinking completely blind.
Our pipe has reached the bottom of that liquid metal ocean. It's hit solid ground. We've made it to the final layer. We are at the very heart of our planet, the solid inner core.
Now you're probably thinking, wait a minute, if it's hotter than the sun's surface, how is it solid? And the answer is just one word: pressure. The weight of the entire planet is pushing down on it, an unbelievable 3.6 million times the pressure at sea level. It's so intense it literally forces the iron and nickel atoms to lock together into a solid crystal. So it's time to fire up that laser one more time.
As we drill closer and closer to the exact center, something really strange starts to happen. We begin to feel weightless. Now, this isn't because gravity has disappeared. It's actually the complete opposite. It's because the entire mass of the Earth is now pulling on us equally from every single direction at once.
I absolutely love this analogy. It's like you're the rope in a planet-wide game of tug-of-war. At the exact center, every team is pulling with the exact same unbelievable force. And what's the result? You just float there, perfectly balanced right in the middle of it all.
So, after a century of work, our tunnel is complete. A straight shot from one side of the Earth, clean through to the other. And now comes the fun part. It's time to jump in.
So, assuming we've managed to pump all the air out of the tunnel to get rid of air resistance, the fall would be absolutely incredible. You'd accelerate non-stop for 21 minutes, hitting a top speed of 8 kilometers a second. That's as fast as the International Space Station at the exact moment you rocket through the zero-gravity center.
Now, once you pass the core, the planet's gravity starts pulling you back, acting like a brake. But your momentum is so great, it carries you all the way to the other side. Exactly 42 minutes after you jumped, you'd shoot out the other end of the tunnel. And for just one perfect split second, your speed would hit zero right as you reach the surface.
You did it. You just traveled clear across the entire planet in less time than it takes to order a pizza. But in that one split second of weightlessness at the surface, you face one final all-or-nothing challenge. Are you fast enough to grab the edge before gravity yanks you right back in for an endless fall back and forth? Really makes you think, doesn't it?